Welcome back to ECE 320A. We're working through some review problems for exam number 4, and this is problem number 6 from the fall 2015 exam, which is asking us now to find or design a low-pass filter that is first order, and it's made up of a resistor and an inductor, and it has a bandwidth of 1,500 hertz, and we're required to use a 10 millihenry inductor. And we're also supposed to draw the schematic. And if you already know what that schematic looks like, you can immediately write that down. But let's say that you don't remember and you draw this down. Here's R and here's L, here's the output and here's the input. You can now, via a voltage divider, you can now say, oh, this is SL over the sum of those, which is SL plus R, and you can immediately, hopefully, see, wait a minute, this isn't going to give me a low-pass filter. This is actually going to give me a zero at the origin, which is coming up from the basement. Then I have a pole. That's now a high-pass filter. Uh-oh, that's not what I was asked to design. So this is not the arrangement that you need in this circuit to give you or to produce a low-pass filter. So you can quickly, in very little time, eliminate that particular structure as your answer. And what you can do then is say, well, then I must have to only have one more option in terms of orientation or arrangement of these L's and R's. So here's R, here's L, and let me hope that this particular combination is going to work. So that now I have, in terms of Laplace transform notation, V sub 0 of S via voltage divider is R over SL plus R. Oh, good, this is looking better, times V sub I of S. This now has a pole in the denominator, nothing in the numerator, so I'm going to be flat, and then I'm going to be rolling off. Now what I need to do is find that particular point, and that's going to be at the pole location, and my pole is given to me by the value of S that causes that to vanish. And if I solve that for S, I now see that that's minus R over L. And my frequency then, my break frequency, is this R over L. But I wanted that to be 1,500 hertz. And omega is in radians, which is 2 pi times F. My F is 1,500. So I now have this for my break frequency, or I now have 3,000 pi for omega sub b, and I know what L needs to be. L was required to be 0.01 or 10 millihenries, so that now I know exactly what R needs to be to give me what I want. R now needs to be 0.01 times 3,000 pi. Or I now have, taking two zeros off of that 3,000, I now have 30 pi, or roughly 90, a little bit more than 90 for my resistor in ohms, and my L is 0.01 henries, and my structure, I already know, that's now, whoops, I wanted first order, so this is now 94.25 ohms, and this is 0.01 henries. That's what I need to give me the low-pass filter that was requested to have a bandwidth of 1,500 hertz.